Module 15, we will go over the last module from this semester. We will talk about graphs. So what is the graphs? Usually we don't see that much when we do the data structure, but actually that will be a very popular structure when we talk about the transportation. So this one, sometime in the airport, you may see that from the SFO. So you can see from SFO, we can fly to different cities. Sometimes maybe we can have a direct flight to Chicago. Or sometimes we have the indirect flight. We need to transfer from San Francisco to Chicago. Then we can go to Boston. But also sometimes you can see here, they even didn't show we have the direct flight to San Francisco. From San Francisco to Los Angeles. But we can go to Denver. Then we can fly to Los Angeles. So this kind of graph, this kind of the route for the transportation, we call that the graphs. Not only in the airport, when you take the BART, you will see they have different route. So we have the Bay Point train to go to the San Francisco. So you have different stop. So all those kind of route to show where we can go, we call that the graphs. So the graphs, you can see they have the dot here. We say that's the node. So usually the node represent a city and a location. So if between two cities they have a link, or we say the two nodes they have the link, that means we can travel from one node to the other node. So that's how we will make the graph. So in this week, we will talk about the graph. How should we build up the graph? The graphs, we call that the ultimate link structure, because sometimes all the nodes not all be connected. So it depends on your node and your link. So we will see how should we, based on the information we have, we can build up our graph. So usually we say that's the database. And in real life, we say that's the map, right? In the Google map, or you using the Apple map, they are all the map to show you have your location and how you will connect them together. So after we build up our database, or we say the map, then sometimes we want to find from point A to point B, what kind of route I can go there. Sometimes we can take highway, sometimes we can take the local. So it depends on what you want to do. You want to find the shortest route or cheapest route. So that's what we will all discover in this module. So at the end, we will talk about how to find the cheapest route using the Dijkstra algorithm. So the first thing, let's see how should we build up our database. So just like earlier, you see the graph, right? We have the node, we have the link. So that's the two important things how we build up our graph. So that's why usually when we need to have a node. So in the programming point of view, we know we should have a struct for the node. Because this node you will see here, for example, San Francisco, I need to know this node. What is the name for this node? And you see from this node, you connect one link, two link, three link, four link. So from this node go to different link, they can go to other different node. So that's why here we will see what the data attribute we need to struct the node in the node struct. So when we have our struct node, so that's allowed to have the number of the link to connect to other node. So then they have the freedom to link to any other node if they have. And also sometimes they even can go back to itself, but usually just not for the transportation. But those kind of data structure, that's what we call the graph. So in our example, we just see using the transportation point of view, we will travel from city to city. We will see from that situation, how should we struct our node. So that's node struct, we will need to think about what should we have. Right, just like earlier we said, they maybe have the city name, they need to have different link to go to other node. So that's why here the nodes contain a couple of things. The first thing, that's their data value. Just like earlier we say, you maybe have the name, that's the city name. So then also we need to know they may have the link connect from the host node to other node. So then you also have some other checking variable. So this one we will see later when we build up our route or when we iterate our graph. We need to save some information. But here, just focus on these two first. So then you all agree. So if we have a struct node, we just say here we consider is the transportation node. So then we have the string that's called the city name. So that's here the string data attribute called city just mean the name of the city. So then let's think about the link. So like earlier we say the links to other nodes, right? So I may have multiple link. So on the other hand, I'm not have one data only. I need to have a group of the data. So this group of data, actually the link, for each link, you are connect to other nodes. So that's why here we were using the list. List, we use that for when we implement the training hash table. So that's why here we just say we use the node, the list of the node. So that's our collection of the link to connect to other node. So that's why we call the neighbors. So see here is our node struct. So just initial version. So don't worry, actually we will have more information. But now we just see what we do is we just do like this. Or we only have the link to from one node to the other node. So then we just do like this. So here our node struct we have city and the neighbor of the list. But you can see from the graph we showed you earlier, they have many different nodes, right? So that's why I have multiple nodes. So how should I save the multiple nodes as my database? So that's why we need to have another data structure to save all the node information. So that's using the vector. So actually which one you want to use doesn't matter, but here because we don't need to have our nodes have any order, so then we just kind of like use the vector like the dynamic array, so we can add one by one. And also the most thing why we like to have a vector, because we can using the index to access that. So this we call the database. So this database contain all the nodes. So each node they have their name and their neighbors link. So whenever we find a new node, we just need to push to the database. So after we have the vector content with the node for database, using each index we can access the data. So that's why let's see again how we will access our node for our neighbor. So like earlier we say our neighbor is a list of the nodes, right? That my data type actually is the node. So then I can have iterator it to traverse from begin to the end. So here if you use the it, they are using the reference it to refer to the data type that will be the node. However, now since you see here, we have the database is a vector. So we can access by the index, right? So on the other hand, actually each node, they have their index to represent for. So that's to make our struct, the list for the neighbor can be a little easier or smaller data size. Instead here we're using the list of the node pointer. So then actually we can change to the integer. So this integer actually mean what? That means actually we have our vector database, right? So here I don't need to have the list to save all the nodes. Actually that's occupy more memory. So here I just can simply to refer to all the index for the neighbor. So that will be easier to access. So whenever you want to traverse your neighbor's list, you still can have a constant iterator it. But this it actually is an integer, right? So that's why you still start from the beginning to the end. But every time after I want to dereference to access the neighbor information, I'm using the it dereference associate with my database vector. So that's how we can get from the neighbor information. Okay, so we kind of got ready for our information, right? So now here is how should we build out the database. So that's why here we will see, we just say we have all the information, the survey information in a text file. So that's why here you will see in the text file, the city.txt file, you can download from that. So actually they have the information about the star city and city, and also we do have the distance. Yeah, but here since we only want to build up the to show you how to read from the file to build out the database first. So we don't need for the distance information. We just need to know, can they connect or not? So that's why usually when we build up the electric map, they are the same thing. You need to parse in from the text file. So then you read the information into your database. So then see here, we just say each data, they have the star city and city, star city and city. And also just, we also assume now when I read the Eureka to COMSC210, we also have the link from COMSC210 to Eureka. So then we will read the text file one by one to build up our database. So to help you to parsing the file and to save the information to the neighbor, so we will see here. I will just give you the sample file first. So now we see the content. You see now the first thing we have the node struct. So you have each node, you have your name of the city and your neighbor information. So then you know how to open the file. So that's why you have database vector. So right, so now when the file is good, we just need to read from the from city to end city. So every time when you get the line, okay, so when you get the line, we save in the from city. As long as the from city not equal to the end of file. That's our text file, we have the end of file at the end. So then we just need to get the line for the next for the to city. So here you can see that's our cities.txt file. So you see we have each line, we have from city to city. So far we don't care about the distance yet. So then we have a dash line, then we can start from the next one. So that's why now I want you to run this program I show you. So this one is we call the database build.cpp file. So this one is my sample driver program to show you how to read from the text file. So you will download this one, then you can run from your program. So don't forget, you also need to download the cities.txt file under your project. So then we will see here we have our node struct. Okay. So then, yeah, here actually we don't have the it's visited yet. So that's why you can remove this one first. Okay, so then when we start build our database, we have our node vector. So then every time you see, you just need to read. You get one line for the from city, one line for the end city. So here, as long as the file is good, we just continue to read. But we will ignore the distance for now. Then we ignore the separator for now. So the most important thing is after we know the from city and to city, I need to add to our database, right? So that's why here, let's give them their index first. So we just call, we have the from city is the I2 node index. That's set equal to -1 first. Then you have the 2 as well. So then here we just searching for the current database. Do I have our from city or not? If we have, great, break that because I need the I. Otherwise, I just need to add the new one. You see, so then if the I finish equal to the size, that means I need to add new city. So that's you push in. Otherwise, you have your I equal to